Okay, now this session's been recorded. So let me start off by introducing myself. My name is Tim Robinson. I'm a developer advocate in IBM's Digital Business Group. And I'm going to spend some time today talking about our Watson Developer Cloud, Watson Services, and also using Watson Services through Bluemix. I'm going to be doing this by going through an example application. We'll keep this coverage of the application pretty high level and some of the results of the application pretty high level, but I do want to show you some of the capabilities that the application illustrates that can be accomplished. This is a sample application. It's not an IBM product or IBM service. It's an example of something that could be built. It is a GitHub project, so you'll be able to take a look at the full source on your own time if you're interested to learn more about how it works. We'll spend some time going through the architecture of how it works with an eye towards understanding a bit of Watson and Bluemix capabilities. And we're going to transition over to covering the Watson Developer Cloud and the services that are available through Watson Services in addition to the ones that are showed as part of the application sample. Show you where to find the Watson software developer kits for the various languages. Spend some time going through how to explore the capabilities of a particular Watson service. When you're in a hackathon and you want to find out what these things do, it's great to have demos that you can kick the tires with, and I'll show you how to find those for the various Watson services. And then we'll transition over to some common scenarios of using Bluemix and give you a chance to see the Bluemix user interface. Hopefully, if it's your first time seeing the Bluemix interface, that when you start using Bluemix, that this introduction will give you a little bit more comfort with using Bluemix. And then we'll wrap up with some links and some other contact information so that you can get in touch with us at and during the hackathon. So with that, I'll talk a little bit about a use case. So here's an interesting use case around content that's very common in media and entertainment. And the use case we're going to talk about is the large amount of data that's represented in video content. As we know, the amount of data on the internet is exploding, and a big portion of this is user-created content and content that is appearing from everywhere on the internet that's video content. Now, there's lots of bytes of data associated with videos, but there's also a lot of unstructured information, content. What is this video about? Who is in this video? All these kinds of things that we might want to be able to characterize more. I'm going to show you an application that was developed by one of our Bluemix developer advocates, and it's about learning about and tagging content in video. So what can we learn from video? First of all, think about a video as a combination of modes of information. There's a series of images appearing in a stream, and pardon the pun here, there's a river here with a boat. But anyway, if I was able to take a particular image out of that stream and analyze it, I might be able to find an interesting and novel feature, like something in the water or a boat. Images may also include people, right? I might want to be able to identify people within a stream of content within a video. So I might be able to find not just people, but also famous people. So I might want to be able to tag individuals that are famous. Also, you'll see in this image content, places or things of interest, right? So I might be able to identify those things. And all these things are things that I can learn by analyzing, image stills effectively with a video. And this application shows how to go about getting stills out of a video and how to process them with the Watson Visual Recognition Service. And then turning to the other part of a typical video is there's usually an audio track. Right? The audio track could be ambient sounds, it could be music, it could be dialogue, it could be narration. This sample application shows how you can take the text out of either dialogue or narration and process it. And the kind of processing that we can do is we can go through a passage of text and convert that into identify concepts, right? Like a passage might be talking about artificial intelligence. It may not use the words artificial intelligence, but if I can extract that concept, that would be a very valuable thing to have about a particular video stream. I might also be interested in understanding if particular keywords are being used in a video stream, keywords like nanotechnology, for example. And similarly, as to identifying celebrities in terms of faces, I might also want to be able to identify entities within that text stream. So for example, tell me all of the videos in this collection where Kim Kardashian is mentioned. Right? So here's a sample example application that can do that. This application is called Dark Vision. And I want to go through it just to give you a sense of some of the things that can be done. This is not necessarily the only way to do things, and there's a lot of things that are left open-ended in terms of which tags are accepted and what we do with them, so that you can see the features of the services. I'm going to jump over here now to the screen. So this is Dark Vision is a project. It's a sample application. It's available on GitHub, and you can clone it to create your own copy. I've cloned it here to create my copy, and I've uploaded some content into it. We'll take a look at some of the tagging of that content in a moment. I'm going to upload another bit of content so you can see how quickly it processes these things. We've got a commercial here, which is a commercial of Watson interviewing Victoria Stilwell, who's known for her work with dog and dog behavior. And click on continue. Log in. I'll explain that login stuff in a bit when we're talking about you're making your own copy of this from GitHub. So as you can see here, the video is uploading. It's almost done already. Nice fast internet performance here on this Friday before the holiday weekend. And while that video is processing, I want to tell you a little bit about kinds of things that you can see with image tagging in video. So one of my hobbies is flying model rockets, and this spring I was out in Northern California with some students from Lodi and Manteca schools, and these students have been building what we call CanSat payloads. It's about the size of a soda can. We put them inside a rocket, we send the rocket up, and the CanSat gathers a bunch of data. It's a great STEM thing. This particular video, as I go into it, I've got the overview page from this application. The application overview shows the number of frames that were extracted from the video, and it shows the keywords that have been identified. You'll see here entities and concepts are blank, and the reason for this is that this particular video doesn't have a particularly fascinating audio track. It's got a countdown and the sound of a rocket. So there isn't much that's been done here in terms of creating an audio track that can then be looked at with any Watson services like the Natural Language Understanding service. But instead, I'll see here just some image keywords. I want to focus on one of these frames. Here's a collection of image keywords across the entire video. Let's look at one still. And I want to talk about what we're seeing here. So image keyword list here, these are actually called classes. And when we say a class is something that the Watson Visual Recognition Service has identified that may be present in an image. And in addition to returning an array of classes from analyzing a particular image, you'll also get back what's a confidence level, which is a number between 0 and 1. Now, in this application, that's being shown as a percent, but it's better to think of this as just a way of saying, from a confidence perspective, what is the confidence that a particular feature or a class is present in the image? Now, the kinds of features that Watson Visual Recognition can produce without any training are quite varied. So we can get features that describe the type of scene. For example, this is a nature scene. We also get some features that describe characteristics of elements within the scene, like a hill or a hillock, a hillside and a slope. And then in addition to those features from the scene, there's also characteristics. So there's a greenish color to it. I'm going to go to take a look at another image here as well. This is an image of the rocket that's actually going up. And here we can see again a wide range of classes with differing and decreasing level of confidence. But all these are quite accurate classifications. You see here a jet engine. And this is one of the challenges in some ways of looking at this data. There's no jet or other plane identified. So if you're running a real application, you might want to do some additionally filtering of these classes and say, okay, there's no airplane identified in this scene. So maybe I don't want to keep this particular jet engine class, instead focus on the concept that this is actually a rocket, right? In addition to the object classifications, again, we get a really good classification on color. So let's look at a video that does something with a bit more audio track to it. I'll go ahead and jump over to this video here. This is another one of these commercials where Watson is doing a bit of narration. And here, there is an audio track which is present, so that's being extracted and being analyzed. The Watson service is a natural language understanding service, is able to pull out keywords, pulled out the keyword biomarker data and data points. These are all very logical things to expect in a video about Watson and health. And it also successfully pulls out entities. It pulls out the mention of Medtronic as a company and also Watson. So a little bit of a meta thing. Watson can recognize itself. I'll go into one of these images to show you some other kinds of tagging that this application demonstrates. So here we have, in this case, it actually is a patient sitting in a room. If you were to watch the entire video, you would see an interaction between a doctor and this individual. So Watson comes up with a rating of a patient at a moderate probability. Similarly with the doctor, it's tough for Watson to tell exactly the context of this scene to that level of detail. But Watson is also successful in identifying a face of a person. So we know there's a person here and identified this as being a male between the and also an estimate of age. So there's some pretty rich information that can come from these services. And again, this is something that has not been trained at all for this data. This is just videos that I have uploaded into the application that have been processed. Let's take a quick reload here. I'm going to try to upload the video one more time. It's fast. Okay, while that's running, I'll point out some other images that I've uploaded here. This is an image from the Black Rock Desert at sunset. Again, very good classifiers here. This is an example of identification of celebrities. So we've been able to identify particular celebrities. The Watson Visual Recognition Service contains a database of images of celebrities, and it's relatively accurate. I'd say that sometimes, you know, when you have a face that's not straight on or things like this, it's difficult to make an identification. But we will also return back our quality of classifications here. And when you're running this service, you'll see when it's processing a video, it provides some dialogue on the bottom. I ran this with a stopwatch. This is actually a 30-second piece, and when I ran it with a stopwatch, it took about a minute. And most of that time is actually in processing of the audio track, and it's almost done. And it looks like it's finished. So I'll reload the page. You might find that if you're using a copy of this application on your own, that you might have to reload the page after processing content so that it shows up in the list. Again, this is a sample application, so there are some things that, you know, features and bells and whistles that we wouldn't put into as not a production thing. I do want to show some more work on classification here. Here is a scene where we have a set of books in a shelf, and Watson Visual Recognition thinks this could be in a library, which is a pretty good classifier. Shot within a building, and we've identified another person within the frame. Scroll down here, and this is Rusty. He's a dog, and actually there's a narration between Watson and Rusty. But the good thing to see here is not only the breadth, but also the detail. So animal, we've got a domestic animal, it's a dog, hound dog, and then a beagle. So you can see we can get down not just identifying key features, but very detailed types of things, features that we can. Again, this is an untrained service. This is the service out of the box without training. Okay, back here. I'll stop my video so I'm not crowding the screen and the recording for later on. And so I like to spend a little bit of time talking about how this application works. So this application is an application running on Bluemix, and the web UI that you were seeing in the application is a Node.js application running as what's called a Cloud Foundry runtime application. We'll get into a little bit more about Cloud Foundry when we take our tour of Bluemix in a moment. The web UI implements a simple REST API, and when that REST API is used to upload the image or video content into a Cloudant database, once the data goes into Cloudant, that creates a trigger to run our event processing system. IBM uses OpenWhisk project from Apache as a way to provide event or serverless-based computing. One of the very interesting things about serverless computing for this particular application scenario is that serverless computing can scale and handle events as they come in. So there isn't a VM or a runtime or an instance that you stand up. Essentially, whenever a unit of work comes in, the serverless computing system fires off the request to process through OpenWhisk. Now, what is processed are these things called actions. And down here in the bottom are a series of actions. I'll go into a little bit more detail on how they work for this application. But actions are run as a result of triggers or events by OpenWhisk, and actions can be written in a number of programming languages. For this particular project, we have a couple of JavaScript or Node.js actions, and then we also have a video extractor which runs as a Docker container image. So there's a Docker container that executes the action. What do these actions do? So when we have the image coming in, the video coming in at first, video goes in through the REST API and gets stored into the cloud database. And this runs an OpenWhisk action, which does a video extraction. The video extraction, again, is a Docker container, and it runs a program that pulls out frames at set number of frames for a particular video track. If you decide to make a copy of this application and build your own container for this action, you can adjust that number of frames, take more or less out of the video. In addition to pulling out individual frames, it takes the audio track out of the video and stores all of that back into Cloudant. Once an image frame is stored in Cloudant, that creates another event, which OpenWhisk uses to fire off an action to do an image analysis. The image is then processed using Watson Visual Recognition. Watson Visual Recognition returns back the classes and the confidence levels for each class, and then that's stored back into the Cloud database along with the image. And if you can dive into the Cloud database if you want to here and take a look at image by image, and you'll see the classes that are stored right with it in the database. The audio track comes into Cloudant, and that triggers another OpenWhisk action. And that OpenWhisk action is to get the transcript of the audio track. And to get the transcript, we send the audio track as a stream to watch and speech to text. That's processed asynchronously there. When watch and speech to text returns back with the stream, then we have another action which saves the transcript into Cloudant. Now that we have a transcript of the video content, we take that and run that through a text analysis using Watson natural language understanding. And I didn't talk about this when I was going through the results of the analysis, but what we do with natural language understanding is we select particular features. In particular, we are taking out the keywords, entities, concepts, and emotion features with natural language understanding. Okay, so that was what I wanted to cover at a high level about the dark vision application and as sort of a scenario. I'm going to go ahead and pause here at this point and take any questions. I've got one question that's come in from the chat. The question is, are the audio and visual analyzed 100% independently? That's a really good question. And in this particular sample application, yes, they are. So that is an option, in fact, to get higher correlation. For example, if we are looking at an image where I've identified a particular personality, and I also have an audio where I pull in a keyword match for a person's name as an entity, then I would be able to correlate those two things appearing and then have a much higher degree of confidence that, in fact, Guy Fieri is in this video. So that's a really good point and question. Any other questions? No? Okay. All right, so I'd like to take a moment now and move over and show you a bit more about the Watson Developer Cloud environment and get you your bearings so that you can learn more about the various Watson services that are available for you to use in projects for the hackathon. Now, again, you don't need to rush to copy these links. We will have a slide at the end that has a web page that will be available with links to this content and other content as well that you can use throughout the hackathon. So this is the Watson Developer Cloud homepage, and the Watson Developer Cloud provides a set of services. Before I dive into these particular services, I want to take a step back and talk a little bit about Watson and the history of Watson. Some of you may remember that Watson was a system that was purpose-built for playing Jeopardy, and it did very well at that. At the time that it was built, it was a very great internet crawler. It analyzed a lot of data on the internet. It built fascinating and rich relationships between entities, and it got very good at creating answers for questions, creating questions for the answer clues that were given in Jeopardy. But at the time, Watson was really a monolith. And what we've done since that time, when Watson was very successful playing Jeopardy, is we've taken this monolith and we've broken it down into a series of components across a set of dimensions, and we've added some additional features. So a lot of the stuff to the left-hand side, the language features, are key elements of what were part of some of the system that played Jeopardy very well. And they're all about dealing with and working with language. There's some features that are pretty good in terms of being able to create features like chatbots. For example, the conversation service allows you to be able to take input as intents using natural language classifier to identify what someone's asking, and then drive a dialogue and provide responses back. We won't go into a lot of detail of conversation, but there are some very good demos that you can access later about that. In addition to the language-based processing capabilities of Watson, there are speech processing capabilities. We both convert speech to text and text to speech. Watson provides an image or vision capability through the visual recognition service, and we saw some of the examples there, and we'll talk a bit more about that service in a moment. And then we also have content analytics and discovery services to provide insights about content. So before I go into a particular service and show you how to explore services, I want to go and show you how to get access to the SDKs for Watson. So from the Watson Developer Cloud page, if you just scroll down, you'll see links here to all of our SDKs for various languages. These are exposed out on GitHub. And the way they're structured is that the project will have a series of folders for each of the SDK areas. And then down in the README, we've got one section which talks about the general concerns for using across the various SDKs, and then service-specific examples. Let's dig down here into visual recognition. So each one of these service-specific examples provides information about how to use the particular API, those 10 lines that you need as a developer to be able to make it work. So here's the example for visual recognition. That's all it takes. I bring in the SDK, I create a variable associated with an instance, and I provide some parameters, and I call the classifier. And that's pretty much all there is to it. And I get back my JSON object, which contains the output from Watson. Okay. So let me roll back here. I'm going to go back up to the Watson Developer Cloud and show you how you can explore these various services so that you can learn more about what they do. And the one I'm going to pick on, I'm going to continue to pick on visual recognition. And I'll start here by saying something a bit about the Watson services in general. So the Watson services sort of come in a few kinds of flavors in addition to the dimensionalities we talked about before in terms of language, speech, vision, and content analytics. Some of these services are trained, and some of these services can be enhanced by further training. Visual recognition is a little bit of both. Visual recognition has been pre-trained to be able to analyze images for, as it says here, scenes, objects, faces, colors, food, and it can be trained through your own custom image classifiers too. So let me show you examples of this particular service, and you can do this for any one of these services. We have demo versions of the applications. These demo versions of the applications are hosted on Bluemix, and they're available in source format on GitHub. I'm going to pick one of these images. I'm going to pick this one here. This obviously looks like food, and Watson agrees. When Watson provides output. This is what you're going to get from Watson. It's going to look like this. It's up to you as a developer to figure out what you're going to do. You can clip things off, right? If it's a relatively low classification level, you don't have to keep that result. You might want to keep the top 5 results. I'll go back here to this to show one more point. So in addition to identifying that we have something that's food, Watson, in particular in the domain of food, Watson is able to go a little bit further and do classifiers and create classifiers that match what Watson sees or believes it sees within that food item. Okay, and we have some other examples here. Of course, I picked this one here as an example of recognizing faces. We get people, come back with an age, and the confidence level on the age. And I can't tell you for sure why the confidence level is as low as it is, but it could be because when you're smiling and you get wrinkles. I know that when I smile and I get wrinkles, my age looks, I think it looks older than I do. Anyway, you can use this capability to examine any of the Watson services. You might be curious to see if you get your own data, you can do that too. So I'm gonna, instead of picking something from my computer, let's do something totally at random. This week, American Airlines. So IBM announced, American Airlines announced they're going to be transitioning their user service and also team service applications to IBM clouds and going from a more monolithic to a microservices architecture. So let's just pick an American Airlines image. Let's pick this first image right here. Copy image address, paste it in. Uh-oh. Let me reload the page. There we go. Sorry about that. Okay, so we think it's a jet, and so does Watson. Okay. So I'd like to shift over now to scenarios of using Watson services with Bluemix. And I think I've picked enough on visual recognition. Let's go ahead and work through an example with natural language understanding. And what I want to show you here is a case where if you've identified that you want to go ahead and work with a particular Watson service, what are the steps needed to create your copy of that service, to configure an application to use that service? And we're going to configure a local application using that service, and also show you how to, once I'm happy with that application, how to push it up to Bluemix. While we're doing that, we're going to be taking a tour and looking at some capabilities of the Bluemix user interface. I'll also be pointing out a few features of that deployed copy of the dark vision application. So I'm going to pick on natural language understanding. And when you go into the demo for these, each one of these demos is going to have a link to the GitHub project. And I'm going to scroll down here a little bit, and you'll see for each one of these examples, we have instructions on how to get started with the application. And this application, these applications that you see for the demos are all Cloud Foundry style of applications. And a Cloud Foundry style of application is something that's essentially written to work as either a web application or a REST API application or anything else that exposes like an HTTP or WebSockets kind of protocol interface. It could also be used to implement like a mobile backend so that you run a native application on a mobile device and run in Bluemix, the mobile backend, and access it through Cloud Foundry services. So as a Cloud Foundry application, it's going to have an application manifest file, and we'll edit this. I'm going to go ahead and copy this URL, go over to a terminal, and I've already got it pasted over here. So we'll clone this project into the directory. And this is a Node.js project, so I will need to add the dependencies for it if I'm going to run it locally. So I'll do an npm install. Oops. There we go. And while it's doing the install, let's take a look at the application manifest file. Okay. Declared services is actually something that's an extension to the Cloud Foundry manifest file format. We won't necessarily need that here, but the key thing to point out here is the declared services define that a service of the type natural language understanding is needed, and its name should be my NLU service. So before we launch this application to run in Bluemix, we're going to need to create a copy of the my NLU service. And in fact, we're going to go ahead and create that now, because we're going to need it for the local copy of our app as well. Before I deploy this app, I'm also going to need to change the name. In Cloud Foundry, by default, the application host name that's used in the URL will match the application name. Host names need to be unique. So in case somebody has natural language understanding demo running already, which is what we were looking at, I'm just going to add my own initials and a date. And I'm going to need to have something called my NLU service. I'll save that file with the change. And let's go to Bluemix. So spend a few moments here. So this is the Bluemix web UI and user dashboard. I'm logged in to Bluemix and I'm in the apps space. Up in the upper right-hand side, you'll see information about your Bluemix session. So it will show your user account name. It'll show your Bluemix region. Bluemix Public is available in a number of regions: US South, London, Sydney, and also in Frankfurt. It'll show you the organization that you're currently using. Organizations are a construct of the Cloud Foundry operational model, as are spaces. And so I'm in the Temro IBM's organization and in the Journey space. Spaces are used in Cloud Foundry to separate out applications and services. All of the services within a space are available for an application to use. And here in this space, I see my one application to the Cloud Foundry application, which is the Dark Vision app. And this is the route that's associated with it. That's that URL that you saw me at before. Then I have a series of services, and each one of these services is being used by the Dark Vision application. Now, I could just go ahead and use this service for the demo that I'm going to do with natural language understanding locally, but I'd rather show you how to create your own service with the catalog. So let's go ahead and do that. One more thing I want to show you before I go to the catalog is that within Cloud Foundry, you're going to see numbers like amount of memory and storage space and number of services and available. So here I've got 672 megabytes running of my 8 gigabyte allocation. This is a quota. When you sign up for Bluemix, you will get a 30-day trial with a set quota of 2 gigabytes of memory and 10 services. That should be good for you getting started. But at the hackathon, if you start to run out of capacity with that, come find us at the IBM table, and we'll be able to give you a promotional code that will both extend your trial and also expand up your capacity for your Bluemix account. So let me go over and create that service now in Watson. So one of the interesting things that Bluemix provides is an integration platform where we can both run cloud application, but also derive and use a wide range of services. There's over 130 different kinds of services in the Bluemix catalog. We've got our Bluemix catalog is organized along the dimensions of infrastructure. And Bluemix infrastructure, you might have known if you've heard of a company called SoftLayer that IBM purchased a few years ago. That's our IBM's infrastructure as a service platform. Those are the compute, storage, network, and security. Bluemix trials provide access to Bluemix applications and services space. Bluemix software infrastructure trials are a separate offering. So when you sign up for the Bluemix trial, you won't be able to deploy virtual machines here, but you can get just as much done, if not more, in less time by using Cloud Foundry applications. We also provide Docker-compatible containers, and then OpenWhisk we've talked a bit about before. So in services, we organize by various categories. Let's go into Watson. And here is our catalog of Watson services, and I want a natural language understanding service instance. And I'm going to use that same name that I saw there in the application manifest file. When I have an application that is already deployed in Bluemix and I want to associate a service with it, I can use this connect to option. Since I haven't deployed the application yet, I'll do that later. I'm going to leave this unbound. This means that the credentials will not be associated with any applications in my current space. Click on the create button. Okay. And when I create a service, I get a control panel for that service. Then that control panel, I have access to the service credentials. I'm going to grab a copy of the credentials right here. So here's a URL. I won't need this for setting this up to run locally. The Watson developer SDKs automatically go to the public URL endpoint. So all you need are the username and password to use these as a REST API, the Watson SDKs. I'll copy those. The other thing I'll point out here, in this particular project, this project is using the Node.js.env package environment. So the setup instructions here are just to create a .env file, and I put in the username and the password. So that's what I'll do. Paste in those credentials. Copy. Paste. Copy. Don't need those. Okay, and we'll start the application. Okay, it's source import 2000. Before going over to show you that application running, now that we have the service instance created, I'm going to go ahead and send this application also up to Bluemix, and then we'll explore it locally while the Bluemix deployment is completing. So to send an application to Bluemix, we use the Bluemix CLI, or you can use the Cloud Foundry CLI. I have the Bluemix CLI installed here. So to send an application to Bluemix, I say bx app push. If I don't specify anything else on the command line, it's going to use the entries from the manifest file, and it's going to work with the content from the current directory. Let's just make sure there's no errors here. Good, no typos, away it goes. Okay, so we've got the local application running on the workstation, listening on port 3000. Go to the browser. Localhost 3000. And here we have natural language understanding. It looks the same as this app because it is the same. Okay, and let's analyze the content of this URL. And here, in addition to some of the features that we saw before in the dark vision application, we have output in some other features areas as well. For example, sentiment. That wasn't one that we saw before, but it is capable and something that's available through the API. In additionally, there's semantic roles that were extracted as well, and in addition to entities. So to learn more about all of these kinds of features, instead of, we don't look at the SDK for this, we actually look at the API reference. And you can get the API references in a number of ways, but each of these demo applications has a link directly to the API reference. Let's go to the API reference for natural language understanding so you can see what that looks like. So this should look relatively familiar. So we have this type of reference available for each of the Watson services. It explains what the REST service endpoints are. It provides examples of invoking them for various languages. So this is sort of, you can think of this as sort of like a supplement to the SDK information. In additionally, it documents the detail of what can be provided to the services. So this can be a good reference so that you can learn more about a particular service. And again, we've got categories, sentiment. One other interesting feature that wasn't shown in the demo application is this notion of relations. So this is another kind of interesting feature that natural language understanding supports. It's the capability of linking entities. So for example, they've given here, you can have a relation of awarded to, like the Nobel Prize was awarded to Albert Einstein. This kind of text analysis is very rich and can get a lot of details out of various text passages. Let's check on our deployment to Bluemix. And I think the answer is moving right along. So talking about what happens with Cloud Foundry applications. When an application is deployed to Bluemix, all of the application artifacts for the application are uploaded to Bluemix, and then they are converted into an object which is then stored in a blob store. And then when it's time to start an instance, that object is copied down to a container called that runs inside of a cell, and then that application instance is started. The application instance is started, it's associated with a route, and then traffic is then mapped into the application instance. Okay. While that's finishing up, actually it's just about to finish starting here. I was going to check and see if we had any questions about, okay, no, I'm going to sign that no questions coming in the chat. So let's come over to the to the Bluemix dashboard. And to navigate around in Bluemix, we have this little hamburger menu up here. Click on this, and there are categories. There's a services set of view, there's an app set of view, and an infrastructure view. Infrastructure view is, again, for those software components. Services view, there's a dashboard that shows me all of my services. And there's an apps view, which I can use to see all of my apps. And so now we see here, in addition to the OpenWhisk Dark Vision app that we were looking at before, we have the natural language understanding app that's running. And we see its state is actually up as running. I go to the URL by clicking on the name. And this is the same thing. Now, what I had running locally is now running as an application in Bluemix. You have your app running up in Bluemix. If you want to learn more about it, you can click in here to bring up the application dashboard. Within the application dashboard, I have a series of capabilities that I can navigate through over here. The overview gives me a look at my application. It shows me how many instances I have running. One of the strengths of Cloud Foundry is that it supports horizontal scaling very effectively. If your application is able to run with multiple instances, and there's some guidance that we can give you on how to do that, then you can scale it up to a very high degree of scale through horizontal scaling by just increasing the number of instances. If you need to do vertical scaling of the app, like adding more memory, that's also an option. Not the best thing, because eventually you run out of gas on memory. And additionally, the overview shows you the connections. So here's that my NLU service is associated with the application and being used by the app. I can look at the particular runtime and find details of the runtime. I can see what's going on with how much memory is currently being used by my app. I can also see environment variables. One of the patterns that Bluemix supports is this notion of providing credentials for applications to use through the environment. You saw how earlier to run locally where you're using the .env file. That's an okay thing to do, but you have to be careful. You want to make sure that the .env file is in your gitignore file because you don't want to accidentally push something with your credentials up to a public repository like GitHub. The preferred pattern for consuming services, and the Watson SDK services do this all automatically, is to be able to use an environment variable like vcap services. And here you'll see that in vcap services, that service which I have bound to the application, all the credentials appear for here as well. And in fact, I could go back to my workstation and remove that .env file and then push the file, and the application would still work because it actually grabs all of its credentials here from vcap services. If you want to see what's going on with your app in terms of logging, so let's go back here to our dashboard. Oh, I got a React message here, right? Well, let's use the app here in Bluemix. I'm going to get the same results I got before. Well, the reason I did that is I want to show you, if you want to see logs from your application in Bluemix, the style that you want to use is just write anything out to standard out, write it out to the console, and we will collect it. So all of that information, what comes from the application through standard out, in addition to the Bluemix components, will appear here in the logs page. You can access this through the web UI, or you can also use the CLI to see it. I'm going to scroll down here. Okay, and here's some messages from the app as it's being processed. You'll see traffic coming into the application. I didn't get my React error here. But anyway, anything that your application sends out, writes out to standard out, apparently it didn't write at that time, will appear here in the logs. So before I wrap up, I want to show you one more thing here. Over here in the GitHub project for Dark Vision, you'll find that there's a really good README that goes into a lot of the details of this application and some explanation use cases. It talks about the particular services that are being used, has some similar diagrams to the ones that I was showing from the slides, and explanation and narration of how the components work. And then further, when you're ready to try this out, all you need to do is register for Bluemix and click on this Deploy to Bluemix button. That will start up something called Bluemix Continuous Delivery Toolchain, which is our way of providing DevOps automation for application deployment to Bluemix. We'll run something called a delivery pipeline, and the steps here are very simple. Click on this button. You can provide a name, because you can have your own name for the application. You can also set username and password to make sure that you are the one who are able to upload content to the application, and then click on Create. And that will get you your own copy of Dark Vision so that you can try it out and see how all this works. So with that, I'm going to skip ahead here to our wrap-up slide and see if there are any questions in on the chat this time. Okay. We'll go ahead and open up. Let's go over here. So again, here's some URLs you can go ahead and use to sign up for Bluemix. Our website that has a microsite for the actual hackathon is here, ibm.biz shapehack.info. The GitHub repository for Dark Vision is linked here. And additionally, our team is already joining up with the ShapeHack 17 Slack team. And there is a channel for IBM Challenge for the IBM sponsor competition. And I'm at Timo over on that Slack team. Also, if you want to reach out to the Watson folks and the Watson developer community, they have their own public Slack team, and there's a Slack channel, Building with Watson. Does visual recognition work on live streams? No. So again, what you saw with the approach here, the extractor pulled out frames, and then the API endpoint was called to analyze a particular image. There will be some folks at the hackathon that we'll be able to talk about some more work that IBM is doing in the area with Watson tagging of media. And there have been some announcements that we've made at the NAB show as well regarding to some of those capabilities. Other questions? Go ahead and if you want to, you can actually unmute yourself, I believe, and ask over the audio stream as well. Okay, no more questions here. I'm looking over my notes. I think I covered most of what I wanted to cover. Thanks for, oops, one more coming in. Oh, so Ed, the question about have an account, can you get credits at the hackathon? Yes, we do have promotional codes, and if your account is locked or you need to get it unlocked, you can go ahead and zip us a message. I think maybe the easiest way to do that is just to send myself or Justin a direct message on the ShapeHack Slack team, and we can get you a promo code. Okay. No other questions? Okay, we got a question about training on data. So that varies from service to service. Really quickly, since we've got a moment here, I'm going to just jump over to the example with visual recognition. And pop back. So visual recognition actually provides a training demo as well that you can do. So you can both look at the training process as a demo, or you can do your own training set. When you talk about training a system like visual recognition, we're talking about creating a unique classifier. Before you saw class examples that we had that were part of the service. This is a good example to sort of get a sense for it. So this insurance claims example shows how particular kinds of things we can train in terms of examples of a broken windshield or a flat tire. There's a motorcycle involved accident, vandalism, and then this is an example of undamaged vehicles. And the way the training works is that you provide a set of 50 or more images of a particular class. So 50 or more examples of flat tires, or 50 more examples of vandalism to a vehicle. And then you can also include negative examples. In other words, this is not a flat tire. So the idea being is that we would train Watson to be able to identify what is a flat tire and things which are examples of not part of the classes. So with that, you can click on train. In addition, you don't have to use these samples. You can create your own set. So you can create a set of positive examples of things to be classified as a particular class, and then you can also provide examples of what that class is not. And then other services have different training techniques, and but one of the common ones is the image training scenarios. So, for example, if you wanted it to be able to pick out a particular iconography, for example, we had a hackathon that was with a large entertainment organization. And there was some particular iconography that people wanted to be able to identify on T-shirts to find out if there was association with particular brands. So if someone walks past a video camera, we could capture that picture, take a look at the T-shirt, and see if they had a particular, say, character or image on that T-shirt. So in that hackathon, they actually built a classifier that would identify a particular icon from that brand and identify individuals who walked by with that on their shirt. Yeah, so then a question in more detail about the different classes, and minor, moderate. Yeah, you could do that. You'd probably need to experiment around with the service, and it really depends on the kind of scenario you're trying to address too. Okay, great. Well, thanks all for coming today. I will we'll grab a copy of the chat transcript and we'll upload that as well as a video from the meeting. And for those of you who are going to be heading out and having a nice long holiday weekend, have a great time. Study up on Bluemix next week. Reach out to us if you want to get some more information. And I hope to see you all at the hackathon next weekend.